the experiments that are going on, I have some experiences in those experiments. I have those sort of skill set that they need. I'm quite motivated to work for that, so I think I make a good case, at least, that it's a strong case that why I want to do a PhD, why I want to do in this particular field, and the places that I've applied to, most of them like sort of good for my field. So I think I can't say that I have a strong chances or whatever, but yeah, I make a strong case. I think now
Right.
it's on them whether
They think you're a good fit.
if they find a better fit than me, it's someone who's more suitable, someone who's more experienced, and of course they'll prefer that. But I think I make a good case.
So got advisors की चिंता नहीं थी. So a lot of people are like, either I'm not finding an advisor or I'm scared of an advisor controlling the next 5 years of my life.
No, I think I don't have a problem with advisors वैसा. क्योंकि I mean it's true when it comes to advisors, it's a fact that how your next 5-6 years are going to be depends entirely on your advisor. There's nothing as dominant factor when it comes to a PhD than a advisor. I think in my case I wasn't I had some idea because I was talking to current PhD people. I had some idea about how the advisors are. But I think like in most of the places, there's a system that you can go there, you can work with the professor. If you don't like their work, you can change
Oh, okay.
or something. There's that sort of flexibility that places give. So I think in that sense, it was not that big of a hassle for me. I haven't heard particularly about someone that don't work with this professor. So I haven't heard anything about that with anyone. So I was just like sort of applying to the places which are doing good work. If they're getting good funding, if they already have PhD students, like a lot of people, if they have a lot of flux going in, and a lot of people are like passing out from under their advisory, they are continuously working on projects. That's the indication that they're potentially good advisors. Of course, some things may vary. For example, some people do not prefer micromanagement.
थोड़ा freedom चाहिए.
थोड़ा freedom चाहिए. Like I usually don't prefer someone calling me every day. Because at the end of the day, report what you did exactly. I would prefer someone, at the end of the week, we have a meeting and we discuss whatever I did, and sort of like I prefer that. A lot of people may prefer meeting every day at the end of the day, but then there are a few people who have heard, not experienced, but heard that they call you at the end of every day, or like every sort of equipment that you get in the lab or everything like that, you have to report each and everything, and people may not like that. Or if you do something wrong, then they sort of like don't take that easy on you. So I do not prefer that. So given that I have experience of like working with a few people, I think like I haven't found that anyone as sort of not a good advisor for me, something like that. So I think that was not a major problem for me.
I was talking to a lot of bio students, at least a couple of them, and advisors का चिंता ज़्यादा रहता है. पर to PhD, I haven't really started, by the way. I mean, it's recording and all, but I just start talking, and whenever I think I can use this, that's when I start. But
Definitely, yeah.
dude, for a second, I was like, if आज भी cancel ना हो जाए. क्या podcast?
क्यों?
Dude, you never know last minute पे क्या होता है. So I also work on Auditors का podcast, or used to. I left. So Anna, she's part of the team.
Okay.
And our very first episode, she's like, I'll get the guest. मिल जाएगा. नहीं मिला. She was बहुत assertiveness और conviction के साथ बोल रही थी, I'll get the guest. Didn't happen. I knew कि नहीं होगा. नहीं, I didn't know नहीं होगा. I'm like, always have a backup.
Yeah,
because you never know end में क्या गलत चला था.
Yeah, definitely, yeah.
So for that one, I'm like, कुछ नहीं होता. First episode.
नहीं मिला.
So how it works is, at least how it worked there, was we'd contact the guest through LinkedIn if we don't have that big of a connection, or if we have the number and we know the guest or privately, then just if I know the guest privately, then I text the person. I'd have a conversation with them, चाय पता नहीं पियेंगे, है ना, वो सब ये podcast पे आओगे. तो अन्ना का वो सीन था इसके साथ.
Who's Anna?
Anna Mitra. She's in the team as well. So she's heading it actually. So उसने text करा अबीर भल्ला को, the guest we wanted, and he replied, but then जिस दिन पे shoot करना था वो हो नहीं पाया, तो वो delay हो गया. Then it happened again, second time पे, then we had to arrange for another guest. Third time भी वही चीज़ हुई, ACWB से कोई मिला नहीं, so we had to arrange with बंजारा. My point is, last moment पे कुछ ना कुछ गलत हो गया, जैसे चला ही जाता है. जैसे when I shot with Aditya, I realized कि my audio, when I tried to sync the audio and video together, it didn't happen for some technical reason. तो मैंने basically sync नहीं हुआ. When I went deeper into the thing, I noticed कि I learned कि audio is recorded in different sample rates. So 44 kilohertz, 48.
Shit.
I recorded in 44.1, which messes up the syncing. If you're
44, yeah. So what are you using right now?
right now, I'm still doing 44.1,
44.1.
but I'm hoping, because I don't know how to use 48 is software mein. Logic Pro I have to use, but I'm not risking it today. Just using Logic Pro right now. So I'm just shooting with GarageBand. I have to sync the clips manually, but it's not that big of a deal. I'll do it. 2 घंटे extra लग गए, कुछ नहीं होता. But it's worth the risk compared to Logic Pro switch करना. हमेशा last phone पे कुछ ना कुछ गड़बड़. That's why I didn't use his tripod. He has a tripod as well, but I'm like, अपना use कर, because I know I can rely on these. उसका it's good, but I just know these. Certainly ज़्यादा है.
No, definitely, yeah.
तो are you working for any clubs or anything?
I am heading the Astronomy Society.
Oh, you
I'm
left the physics talk.
Yeah, I quite left the. I think like
I think senior editor or something. Senior.
I was a senior editor over there, but I left FASAC because, of course, at that time we had Astronomy Club, which was a subset of Physics Society. We started our own society. After that, we transitioned our club from to a society.
Right. Wait, so Physics Society, astronomy ka segment was like a subset of that?
Precisely,
and then
yes.
astronomy was removed from physics and a new society was created.
Yes, we sort of extracted Astronomy Club. We said we don't want to be a club under a society. We want to be a separate society by ourselves. And after a huge, making rounds of professors, HOD, and this admin and stuff like that, we finally got our own society. Yeah, let's, we have our own society. And then we started working. Then I became the secretary. Shweta, she became the president. We started making a team after that. But yeah, I left FASOC. Not particularly because, I wasn't ever an integral part of FASOC. I was always sort of I never felt it's mine. Although I was a editor over
You
there.
didn't feel like you belong. Oh, sense of belonging nahi aati.
Also belonging one thing, and it wasn't as an active society at all.
Oh, okay.
The culture of society, or it wasn't at that time at least. Now it is a little bit, but at that time it wasn't a very active society. There was nothing sort of new happening. It was just a more or less, I thought, sort of a
formality.
Yeah, maybe a formality, but I don't know. Like it wasn't like a very active platform. It wasn't very engaging for general people at Ashoka. And
opening a physics society at Ashoka.
Yeah, exactly. And I think there was nothing much. They weren't contributing much, or nothing like that. Something like that wasn't happening.
The members weren't that enthusiastic.
Some of the members were, but the functioning of the society wasn't sort of bringing anything new to the campus culture.
Right.
And I personally did not like the sort of the dynamics as much about how it's working and how the elections are held. All of that, it was quite partial. Yeah, these people are usually my batchmates and all, but I think when it comes to who's gonna head the society and election and all, that is quite a nepotism kind of a thing over there.
Nepotism is like जो जैसे बॉलीवुड में हो गया, इसका बेटे को रोल मिलेगा इस फिल्म स्टार के.
Exactly.
What's the equivalent here?
Yeah,
this guy has a
चाचा भतीजा वाला काम.
Yeah.
How we call it in Hindi, but yeah, essentially I did not like how the society is sort of, the executive body of the society is formed, and
right.
How it's sort of all powers are so diluted that if you want to get one work done, you have to approach this treasurer, I need this much fund. Then you go to this whatever mailing guy, outreach guy that make a poster, and then you go to the events team, and then you are confused who's gonna make the poster for the event. Is it gonna be the event team, or is it gonna be the contents team, or is it gonna be the outreach team? And then each of them are passing here and there, and then you finally go to the president, let's do it, and they're like, okay, let's take a permission over there. And by the time they take the permission over there, in the eyes of professor, it's like it's them who came up with the idea, not you. And all stuff like that happens. In the end, it's because there are so many departments involved, it's so diluted that there's no end work. It doesn't ever come out.
Just to do one thing, there's so much other stuff that
there's so much other
red tape, I suppose, you have to go through.
Exactly.
Is that the right phrase? I don't know.
Yeah, exactly. And especially, if the people around you are still motivated to make it a big thing, to make a big deal out of it, it still happens. But even if people are not excited to do it, then there's no chance that you can sort of cross all that barriers being a simple member.
Yeah. I think if you would, let's say, when did you join your first club or first society? Do you remember?
I think it was FASOC only, but I think 2022.
So when there's a new project or new anything, literally a new club, new project, new event happening on campus or just in general, बहुत excitement होता है कि physics society, that seems cool, I'm into physics, therefore मुझे मजा आएगा physics society में. नया एस्ट्रोनॉमी का डेटा साइंस का वो खुल रहा है, dude, I'm into data science, I'm proficient at Python, देखते हैं क्या होता है. But then when you actually get to the thing, you realize there's so much work that you just don't enjoy at first sight, but you have to do that.
Definitely.
To get to the interesting stuff.
Definitely. I mean, that's very true. I think like the entire this trajectory of following, like, doing physics at Ashoka or anywhere else, it's a subject that for the first 3.5 years, like till now, I have been just the exact thing that you said, that I'm like, dude, I don't like this. I just don't like this. Like, how do I get through it? Yeah, I just have to pass this time. But only when you sort of pass this 3.5 years, when you reach the 4th year,
become proud.
When you do something that you actually, that's the time when you actually get to do something that you love. For example, right now, finally, I'm getting to work on this AGN feedback and black hole stuff, environment, all of that with Shomak. So for the first 3 years, of course, I was doing some projects on the sides, right? Just summer projects and internships and a bit of that, which is fine. But the coursework, which is like the most of the heavy duty stuff and the most long duration stuff, is something which I wasn't particularly enjoying. Or I felt like, I don't want to, isme to jana nahi hai karke kind of a thing. But you have to go through the 3 years. You have to reach the 4th year to do something that you actually like.
Yeah.
And that's when you realize ki ye 3 saal, they were important. If you remove even 1 or 2 of the courses, I particularly did not enjoy the computational aspect of courses that much. The few courses that I had, they were good, but
I'm assuming you're talking about mathematical physics, MP1, MP2, those courses.
Mathematical physics were there, but exactly. For a course like mathematical physics, now honestly, I wasn't like a big fan of the course, like, crazy thing, but they are crucial. Whether you enjoy them or not, whether you like them or not, whether you found them interesting or not, they are crucial to set up your base. Without those courses, you cannot move forward. Computational physics. Now, no matter what project you're working on, be it theoretical, be it experimental, you have to involve computer today. You have to involve Python, you have to involve programming. Without that, there's not much physics that you can do around.
Yeah.
If you want to, sort of contribute to the physics community, you cannot do just paperwork now. In that sense, even though I was not a big fan of programming and stuff like that, I had to do it through some courses. I had to do it through some projects. Even though I might not have, been a big fan of that, but they contributed a lot to my journey.
So they end up they're helping you at the end.
A lot. Without these few courses, without that sort of developing myself through these courses, I couldn't have done whatever I'm doing today. Or the way, some juniors, very often they come to me saying that, hey, I have this problem in computational physics or whatever, can you help me run with this, or this programming problem, can you figure this out? Right now, I can figure it out. People do come to me with those sort of problems, which sort of makes me feel proud that I did that course, even though I might not have been a big fan of it, but it played a crucial role in my journey.
Right.
When I go out, I see that there were a lot of people who had the chance of doing it, but avoided doing it, just like I would have done at some point of time if I had the choice.
Like they skipped or something, or
they skipped the course out because it was an elective. They did not choose it.
Oh, okay.
They sort of
yeah
jumped through it. Those people, when they go out to work in any sort of industry, if any external internship, they ultimately have to, in some sense, have to rely on their friends who know good programming. So when I went to Caltech, when I was working with Microsoft, a lot of my friends over there were not as great with competition as the project demanded.
Right.
Not just as me, as the project demanded. The project.
And these were other interns from other colleges all over the world. Okay.
So they weren't as
computationally fluent
about the programming languages. They did not. Maybe they know the math. They could do the whole thing on math, but how to change that math to a programming language? How do you that translation process? How do you write that syntax?
Exactly. Down? Yes, it's a different way of thinking.
It's an entirely different way of thinking. The math is exactly the procedures. You know the flowchart, how it's gonna work out and how it should flow.
Yeah.
But then translating that to a programming language, writing the syntax for it. Yeah. That is the creative part of programming, and that is something that not many people are great at. Because of my courses, I had some experience with that, and I could help around those people. Like among my friends, among people who were doing other projects, because of these courses that I could have skipped them, but I did them. And I
Right.
think they eventually paid off because at the end, people knew that, okay, this guy knows some programming, he can help around maybe. And very often we would sit together and, I would help them figure things out. So
Yeah.
these are some things that you can skip, but I would prefer that people should not skip, especially if you're in a technical field, something like chemistry, biophysics, or math or whatever. Computation is not something that should be skipped.
So any computational course you have an option of taking, you should just take that opportunity and do it.
Especially if you're in a technical field, you should take
The
this.
STEM field, I'd say for physics and bio, it's quite important.
Physics,
Even
bio, even chemistry. I mean, like for example, even say math. People may think that it's not important for math, but I saw some, people working on math stuff, and I would see them 80% time was on their computer programming and 20% time on a blackboard.
I mean, for math, it depends on the field, yeah, if I'm being very honest.
It depends on the field, but I mean, like, if you want to put things out, for example, okay, if you're just writing an abstract theoretical paper, you may get around with just doing some sort of a derivations.
Yeah.
But if it's not abstract, if you want to apply it to somewhere, you have to have some experience. For example, there's a huge math around weather forecasting. Huge math, complex math, and the whole Navier-Stokes equation and stuff like that going on around.
P and all that kind of stuff.
All of that, there's no way that you can do it with hand. There's just no way.
No, of course not. Yeah, that's
So,
insane.
and there's a lot of field, for example, this weather forecasting and sort of, a lot related to like this environmental hazards kind of a thing. A lot of probability problems that you can maybe get an equation
Right.
by doing a paper on a hand. Okay, the probability of this event happening is this much. But then
The
figuring
maths
out
change.
that probability is something you cannot do on paper. You need a computer for that.
Right.
So I think a huge part of math, of course, there is a lot of theoretical aspect in physics as well that you can just do without competition, of course. A lot of it is there. If you want to do pure theory, you can do that. But still, to sort of prove that theory works, if you want to prove it through an experiment, not everyone can make a own particle accelerator or something like that. Right?
Yeah.
You need to make a simulation for that.
Experiments are getting more and more expensive to conduct and even more complicated.
Much more complicated. It's a very expensive field.
LHC involved what, $10 billion, 12 billion, and like more than 10,000 scientists.
Exactly. So
It is insane.
it's insane. It's very expensive. Not even every country can afford that.
Yeah.
You need to be part of those collaboration. And even then, I mean, like, it's much easier to just do it on a computer. You have to spend a few $1,000 on this. And
It's
you can
much
sort of
faster.
create a simulation and do it as much as you like.
Yeah.
So if you are good at computation, you can contribute to a cause much faster than someone who's not great at computation. There are people who are not that good at it. They can collaborate with people who are and then contribute in the same way. But then it sort of makes more sense to, just get good at it yourself. Like, why to sort of
Rely on other people
rely on
when
other people's
it's a
skills.
skill that you're gonna use a lot in
A
your
lot,
day.
definitely.
To seek lo na.
And I think like it's okay for the last generation of scientists to not know computation. That is okay.
What makes you say that? Oh, last you mean the one that came before us?
Yeah, like our
Okay.
sort of the grandfather generation or something like father
Like
generation.
Professor Fukin's generation or
Professor Foucault, the professor wala generation. It's okay because like they finished their say PhD 30 years ago. At that time, computer was still not a big thing.
yeah,
It was
1990s.
just 1990s. Computer was still coming up,
Yeah.
so it's still okay
But
to
the-
not be for them to be not proficient in it. But in
For-
today's world, if you're doing physics, not just physics, especially astronomy, chemistry, biology, geography, geology, marine sciences, no matter what field are you doing, geology, whatever, meteorology, whatever that is, you need to be good at computation.
Yeah.
It's going to help you a lot. You may avoid that completely, but at some point of time, you will have to rely on someone else then who can help you figure out this kind of stuff. For example, I did this one project in my second year, which was entirely computational project.
So those are BICE 2022.
2022, something like that, yeah. That was entirely, I was doing with Professor Dipankar Bhattacharya. It was entirely a computational project. I was able to figure out the theory behind how it works. I was able to sort of get the intuition of how it's going to work out and what's giving us what. I wrote the sort of the flowchart of how the program should look like and what steps do I need to do, what sort of functions or whatever I need to do to get my final result. But that translation I didn't know. I wasn't a big fan of programming.
As in you had the flowchart, but how do I write this in Python?
How do I write that in Python? Exactly. What are the steps involved? How do I I know that I'm supposed to run a loop which gives me this.
Loop में exactly जाएगा क्या?
But loop में जाएगा क्या?
और
Loop
while
को लेके
that
कैसे? Yeah, exactly. Like that kind of thing.
stuff.
Maybe not that basic as while and for all, I think,
Yeah.
but something like that. Yeah, how do I write this loop? Not in fact loop. Like how does the flow of the program should go?
Yeah.
Flowchart is one thing, sure, but how do I translate it to computer language now? That sort of I lacked exposure to the language. For example, if I have to find out yes, there's some sine curve and I want to find the time period of this wave. Now I'm gonna do something any basic person, any sort of novice or beginner person would do something like they'll try to chop down the wave and see where the peaks are. See where the time period is, and then
Pretty standard.
something that they would see, see where the peaks are and see what time it is falling on, and then see the time period.
Yeah.
But it turns out that Python has a built-in function called find peaks,
which already
gives you the peaks. So that kind of exposure is something you get when you do the programming. You have to go through it. That's when you learn, and once you have learned it, you realize that shit, you did not have to do all of this trouble. You didn't have to go through all of this sort of meticulous thinking. Yaar, how do I figure this peak out where it is? Python has made they all have this function find peaks, and you can just do something like that.
Wait, though, I get what you're saying. So instead of thinking about how do I write the program that picks out two peaks and calculates the time period, instead of going into the nuts and bolts of the program, you already know that Python has a program like that or a function like that. So सीधा इस्तेमाल करो.
Just इस्तेमाल करो.
फिर विश्वास करो. But my question is this: though, that's kind of how physicists view math, है ना? Bhai, I know the derivative of sine x is cosine x. Is that I haven't used calculus in so long. Is that I know how integrals work. I know all of these different rules. I know linear algebra. I know how this can apply to this system. And that is more than enough for me. I don't need to know the theory of vector spaces or how a vector space is formally defined.
Definitely.
And those pure math properties to use linear algebra in physics. But here's my question. So, the most popular example of unrigorous math being used in physics is, I think, the Dirac delta function. Dirac proposed it, or I don't know kisne kara tha, but someone proposed this function.
Yeah, Dirac.
It's completely absurd, zero everywhere. On one point, it's infinity. Something absurd like that. Mathematicians are like, it's cute how they think this is a function.
Yeah.
But they went berserk. Because it's not a function. It's not even formalized. How the hell are you using it? Physics are like, sahi answer aa raha hai na? Sawal mat karo.
Kar do, haan. The physics, I think, like this, the guy who invented this is Paul Dirac. I think in the 18th or 19th century, I think 19th century.
19th probably, yeah.
In 19th century.
19th century would be 1800s.
1800s, correct.
It would be after that, right? No?
Maybe after that.
20th century mein hoga na?
It should be 20th century.
So 1900s to 2000s ke beech mein. Yeah.
20th century,
Yeah.
I think, and Paul Dirac was a person who was like, he was a sort of a genius in the field. For instance, there was a time that if Paul Dirac says that this is what it is, and this is the reality, no one would question that.
Kind of like von Neumann in that regard.
Exactly. Yeah. Like there are only very few people who are sort of doubtless in the field, that you just don't doubt them.
Yeah.
Like if they've said it, yeah, that's gonna happen. That should be it. They don't make mistakes in their papers. No one can, send them a letter saying, hey, your math is wrong. This is the correct math. No, that it's sort of a genius that Paul Dirac and all of these people had. He introduced this function first, the Dirac delta function, and right now in physics, you use that function as hell. Like it's just there everywhere. You cannot avoid that function. And it's a beautiful, like sort of, when it comes to problem solving and all, it's a beautiful thing. It's applied at so many in quantum mechanics here and all of that. A lot of places it's applied. And yeah, correct. In math, people may not, people may just, they're like, yeah, what the hell is the definition? How is it even working out in the first place?
Yeah.
Like,
it's not formalized. You can't just apply it kaise bhi.
And I think that's a very sort of cute relation that physicists and mathematicians have. For example, we do this very intricate thing in physics, that if there is any sort of derivative, dx by dt is equal to t.
Okay.
Very conveniently, we take this dt up over there, and then it becomes an integral and something like that.
Yeah.
It solves the problem. But if you show that to a mathematician, hey, that dx by dt, just like a simple unitary method, we took that dt and we multiplied it up over there, and it worked out. They'll be like so annoyed at that. It works out. It works out in physics. It solves the problem. So we're like, okay, we don't want to get into the abstract of math.
Yeah.
It's helping us understand the nature and how it's working. So let's go ahead with that.
But here's my thing with that. So first of all, it's insane that we can use such hand-wavy reasoning to predict nature. That's insane in its own right. What's even more insane is you can formalize that hand-wavy thing to make sense. So, there was a Murray Gell-Mann, I think. He was Feynman's contemporary. So Feynman was in one room and Gell-Mann was in another room. He quarks ka wala banda.
I see.
Yeah,
Okay.
Caltech mein.
I see.
So, Gell-Mann was doing some physics as a physicist does. And he had a bunch of equations or something. I can't remember the exact story. So, he didn't know क्या हो रहा था, but what he saw was, or he saw he had properties of a bunch of particles or something, and he didn't know what the hell was going on. This was during the crisis time in particle physics when particles were appearing left, right, and center. So usually हमें पढ़ाते हैं electron, proton, neutron.
Yeah.
हाँ, बस इतना ही है. Which is not the case ever.
Yeah,
there were hundreds of different. We were running out of names actually. So, हाँ, तो Gell-Mann was in this situation. He had a bunch of particles. He didn't know what the hell was happening, but he remembered from one abstract math course he took about Lie groups. And then he saw these abstract weight diagrams or Lie groups in the physics he was doing, and he used that math to predict a new particle, the omega minus omega plus particle. And then it checked. Then it turns out it was right.
It was right there, yeah.
So, I've told you this before. My approach to physics is a bit different. I want to learn the math rigorously because right now I'm thinking, first of all, two problems. If the math isn't formalized and math is the language of nature, then by learning the language, I can predict physics. That's my first belief. Second belief is this. Currently, it's very hard to make fundamental progress in physics. For example, theory of quantum mechanics, we still don't know what xi means, the wave function. Uska interpretations kya, uske फिर भी debates होते रहते हैं. So fundamental progress in physics is really hard. So my belief is, agar मैं pure math करूँगा, I learned the machinery of the math guiding physics. So it's the same as the first one. I can just exhaust that math and then see, or I can just check out all this abstract math and see where I can use this in physics or apply this to physics. Because right now, kya ho raha hai? It's kind of coincidental, right? If physicist takes a pure math course, then they learn that's in physics.
Yeah.
That's exactly what happened with linear algebra. So 100 years ago, people would say that linear algebra has no practical application to physics, and now people would laugh at that sentiment.
No, definitely, yeah. Same, I think, with calculus, something like that. I developed to just, get an area of something and integration and stuff like that. But now look at the application of it in physics.
It is.
Not just in physics, in any sort of scientific field. Calculus is just everywhere. You cannot avoid that. The same thing like the conversation that we had about the, computational thing. Integration. Doing that on a board is quite, if I ask you to, integrate sin x, it's going to be quite easy for you. You can just write it. But now how do you ask a computer to integrate it for you? If you want to write that function in a computer, how do you do that? Now, a beginner would think a lot that they're going to, run a loop which runs at very tiny portions, something like that. They're going to do a big, keep adding on tiny portions of things and run it through a huge loop, something like that. Though that it's not necessary. If you have a little bit of exposure to the language, if you have worked on it a little bit, you'll realize that a Python library, a Python package called SciPy has all the sort of scipy.edu, scipy.integrate. You put the function inside it and it's going to integrate it for you.
Yeah.
Now, if you don't have that exposure, you will not be able to, you will end up thinking that computation is very difficult and you'll never do it.
Right.
But if you don't do it, you will also not realize. So how would one know that there's something like scipy.integrate? Or as a matter of fact, there are hundreds of such integrators like RK4 and a trapezoid method and this method and Newton's root method, whatever method and stuff like that. But unless you are faced with the problem that you have to solve an integration using a computer, now you go to Google and you put how to integrate using Python. And then it tells you all the ways, and then you figure out that, this 3-4 methods are good for me, and you test them on your system.
Yeah.
Whichever works out best, you use that.
Yeah.
You will not reach this level. You will not realize that there are 3-4 maybe 10s or 20s of method of doing that if you don't face the problem in the first place. So if you jump through it, that I'm not good at computation, I don't need that right now. I'm just gonna jump through it. If you jump through it, you'll never get that exposure.
So what's the workaround that you'll find though? You still need that integral.
You will need integral, but I think
avoiding it for now.
No, I mean for example, on what I'm trying to say over here is that people very often they jump when it comes to competition. I was one of those people.
But keep putting it off.
They
अभी
keep
इतनी
putting it
जरूरत
off.
नहीं है, ये बंदा कर लेगा,
ये बंदा कर लेगा, अभी जरूरत नहीं
यहाँ
है,
से कोड उठा लेता हूँ.
या हाँ ये वाला प्रोजेक्ट मुझे कंपटीशन आते नहीं, आई डोंट वांट टू डू दिस प्रोजेक्ट, मैं कुछ और प्रोजेक्ट करूंगा करके. एंड दे अवॉइड इट, कि जब तक अवॉइड होता अवॉइड करते आते हैं. लाइक आई वाजंट अ बिग फैन ऑफ कंपटीशन इन द बिगनिंग. सो आई वाज टेलिंग अबाउट द प्रोजेक्ट, वी फिगर्ड आउट द फ्लो चार्ट ऑफ हाउ द प्रोग्राम शुड फ्लो.
Yeah.
But now, how the hell am I supposed to do it? I was supposed to do a very huge integration in the project, but I didn't know how to tell a computer to do integration. But then, as it turns out, when I faced that problem, my first solution. So that's a mistake that I made, which is that I sort of relied on the project partner.
Okay.
During that time, Shweta Prakash was my project partner, and I
Yeah.
sort of relied on her. Ki she is good at competition. She's quite good at understanding coding and programming and all, and she'll figure it out. I sort of relied on her. Ki I have figured out the math. I have sort of figured out how the program should flow. Now we just need to translate it to competition, coding,
Which she can do.
which she can do.
She knows that.
She knows that. So once I figured that out, I gave it to her. Ki this is what we need to do. And then I stepped back. Ki now you do it. This is your job. And I was thinking, chalo, I'll get my work done. Like, we'll get the code done.
We'll get our work done.
Yeah, I mean, like, we'll get the code done, and whatever results that we get, we can just put in some next formula and go to the next part. And I don't have to go through that trouble of doing the code. So that's how I would sometimes avoid programming.
Right.
It turns out that sometimes when I had to do a project by myself, because it's not necessary that in every project you're going to have a computational partner with you. What if you don't have? What if the other person is even weaker than you?
Yeah.
Then both of you will sort of, either you go to another third person, you have to involve them in your project, which is sort of diluting your responsibilities, which is not, of course, good. You cannot just have as many people as you want. You only want to keep necessary ones. And there are a lot of people who aren't great at competition, which means given that there are people in physics and other fields who are not good at competition, it's an opportunity for you to be good at that. Once you're good at that, once you go outside, for example, I got a few opportunities when I was at Caltech, but people, they would come to me with help. Hey, could you help me? I'm not saying that I can guarantee helping them, but at least they knew that I know something about it.
Yeah.
So anytime in the future as well, they can contact me. Hey, I'm working on this problem. Would you like to work with me?
Yeah.
They would know that I have some sense of physics. They would know I know a little bit of computation.
Yeah.
I can figure things. I can, They would sort of involve me in their project. It's an opportunity for me to learn computation.
Yeah.
I could have also skipped it, which I did in the beginning, but then I realized that it's going to be a stupid thing. I can avoid it for as long as I want, but if I want to stay in this field, I cannot possibly avoid it. It's a fool's move to avoid the integral part of...
Pun intended.
Yeah. Yeah, exactly. So, but... yeah, then I started doing it on my own. I was like, dude, I need to practice it out. I've avoided it for a long time. Even when we used to write lab reports, I would use Excel to plot the plottings and figure out something from there, and not Python. Avoiding. If I can avoid, why shouldn't I avoid? That's not my philosophy. If I can just do it on Excel, I need to click like this and ask it to graph, and I have got it done.
Yeah.
Why should I do the damn coding all thing, all of that? I paid a big price for it. I realized that I am heavily dependent on people around me. Like, no matter what, if I approach a professor, hey, I want to do a project with you, and they ask me, the first question that they ask me is, how good are you at computation? And what do I say then?
You told me Dipankar was...
Yep.
That's what Dipankar asked you?
Exactly. Anyone.
And the first thing you told me, learn Python.
Learn Python. There's no way around. Like, no one can give you a project which is, not involving competition anymore.
Yeah.
So I sort of had to sit down and get the damn thing done, learn the damn thing up. I need to learn this. I need to
It's important.
Get around with it. I cannot keep on procrastinating it. And then I figured out a bit of Python, and I worked with it and became good at it. It's also a skill that it's, people may think that some people are good at competition, and then only they are good at competition, and you can never get good at that's completely wrong.
Yeah.
It's like painting, that although many people are born painters,
I can test that, bro. Okay, I'll take it for now.
I mean, yeah, I think like I've met a lot of people who are, when we were at the same age, when both of us, I used to take many drawing classes in the beginning, just like anyone else, and I figured out that how some of my friends, we both were like say 6-7 years old, both of us have never done a painting class before, but somehow they have better strokes than me. Somehow they can make a straight line, and I can like that. So I wasn't like, you know, that good at painting.
So they're making the straight line and calculating the slope, and that's why you're a physicist.
Yeah.
That's why you're a physicist and they're unemployed.
Yeah.
No, I'm kidding.
Yeah. No, but still, I mean, like, it's a skill that, you know, people are, I mean, of course, it's not correct to say that they're born painters, but some people are like, you know, they're good at it. For example, some people are good at writing.
Right.
That from a young age, they're good at writing, and some people, they just cannot write. They're like, bro, I cannot write. I don't think that's true. For example, although I wasn't great at painting in the beginning, in fact, I think the first or second painting class that I took, a drawing class I took, the teacher said to my mom that he cannot do it right now. Wait for 3-4 more. I was already, I think, 7 or 8 years old, and my friends of my age were doing that. But teacher was like, hey, he can't do it right now. He's too young for it. He cannot even control a pencil properly. Bring him to me after 3-4 years. So I wasn't good at it. But it's something that I always sort of missed. When I would go out, and I'm a big fan of traveling, and when I would go out for traveling, I would see a very beautiful scenery. I would write about it. I can write around a bit. I would write about it. But then I felt that my writing is not actually capturing the entire beauty of it. There's a whole, you know, audio aspect to it. There's a whole imaginary. But I think, like, if I have a painting, there's a whole visual aspect to it then. So I was desperate to improve my painting, and I always sort of had this sort of abstract, this sort of idea in my mind that I cannot get good at it.
Yeah.
I've never been good at it. I cannot paint. I came over here. I did some sort of a, you know, I became sort of desperate to be good at painting. And I think, like, one of my friend and all, they sort of taught me how to paint a bit, and I started painting on my own. I would just look at YouTube videos and stuff like that, and with that desperation that I want to learn, I actually learned. Now I'm not that bad. I'm not great, but I'm not that bad. If you make me, if I need to, you know, sit somewhere outdoors, and if I need to make some sort of a scenery, I can work my way around it.
Right. So you got better.
I got better, exactly. So it's a skill. Painting is I used to think that painting and writing is a skill that either you are gifted with it or you are not. But in my personal experience, I have found that, yeah, some people may be gifted with it, sure. Some people at a very young age, they're good painters. But then there are, most of us can pick it around, can pick it up in our lifetime. You know, just keep on practicing all of that. If you have a good teacher who can teach you well, you can pick it up during your time. Same thing follows with competition. That some people have that logical mind. Some people know exactly that, you know, how will this flowchart work, and if they have a little bit of experience with programming, they can figure their way around. Some people think that, math to hota hi nahi hai. Most of the people, not some people, most of the people think math to hota nahi hai. Programming to hame aati hi nahi hai, hoegi nahi. But that is not true. If you can work around of it a little bit, it's just like painting and writing, that you can pick the skills up. So certainly, I think, being in a technical field, competition is not something that should be skipped.
Or eventually, the way I see it is, every skill is learnable, first of all. Not to mention, let's say I'm not inherently talented in programming. Well, how the hell is that going to help me?
Exactly.
Okay, I'm not inherently talented. Okay. My only option left is to practice.
Yes.
So, I'm a math major. Hopefully. I don't change again. But I'm doing linear algebra, and I do 4 hours of lineal every day. So 4 hours lineal, 20 hours a week, which is more than what a usual student would spend per course.
Definitely, yeah.
But I'm still a class behind. It takes me a lot of time to understand. I'd say I'm slower than your average student. Or maybe I just really want to understand whatever I'm learning. I scrutinize every detail, math ke proof mein. I don't leave anything out or most things out. So even though I do feel I may be slower, it doesn't really bother me because it's not something I can change. It's only something that I can get better at with iteration and feedback, which I am getting better at. Self-studying through a textbook is not the most easiest thing.
Definitely.
So I do see myself getting better. हाँ यार आज 3 पेज होए पर मैं समझा सब कुछ जो मैंने पढ़ा, and that
definitely
it's a really good feeling.
And I think, like, when you're studying a subject like say history or say political science or literature, something like that, you have to sort of read it, and in many cases you may get it as well. For instance, I don't know how such literature-oriented subjects on high-level work. I don't have experience with that. But as far as I have experience in, like, the first and second year of my college, I think that, of course, when it comes to philosophy, you have to put a lot of brain and all into it. But if you just want to, understand the concept of how whatever happened during Napoleon time or whatever the
Huh.
Napoleon's principles or whatever.
Yeah.
You go through it and understand.
Like go through the history of what happened.
Go to the history,
all
go
the
through the
events, wars.
exactly,
Right.
how it impacted and what were the causes of bringing this change. And you see that chronology happen. You see that you can make a pattern very well. Can you sort of get that imprint in your mind sort of just by reading it through?
Yeah.
But that is not the same thing with math. You cannot just read a problem and get a hang of it. Ki what's happening there. You have to,
Absolutely not.
you have to, sort of struggle through it. You have to do it yourself 10 times, 15 times. You have to do multiple. If you're learning integration of how, if you want to actually see how integration works, just looking at a solved problem or just reading through about it won't work.
Yeah.
Maybe even if you give me the best book ever written on integration, if I just read through it, it's not going to help me. I won't understand how integration works.
Yeah.
Unless I do it myself for 10, 15 different functions, for 10 different problems and stuff like that, that's when I realize, okay, this is how this shit is working.
Yes.
So I think it becomes quite important in subjects like these to sit down and do the damn thing for few hours.
Exactly.
Especially with math.
And computation, dude.
And with technical fields, that's a thing that you have to sit down, you have to go through it.
Yeah. I have a question. So we're talking about computation, Abhi. I feel like it's fairly easy to learn the syntax of a language. So Python syntax, as my friend has put it, it's literally executable English. It's fairly straightforward.
True.
If then while makes sense intuitively. But when you're writing a program for the first time, like something relatively simple, you're writing a formula to sum up the first n terms of a sequence. I remember I was doing it. It took me so long, bhai. 4 or 5 hours I was spending, and I knew the solution was there. I could read it up, and I did that after 3 hours. So I read the solution, and then my trick is recreate it. Do not look at the solution, recreate it. And that's when you will find holes in your logic. So before coming to college, I'm like, Python is something I should learn if I want to major in physics, and I should do quite a bit of math. That will prepare me, set me very well for physics.